Hello guys, in this video I'll be explaining my assignment. As you all know that I am Mohammad Hasnan, and I will be explaining this assignment related to digital logic design. The assignment is about the number system conversion. Like in this question we are given we have to convert decimal to binary, binary to octal, and similarly binary back to decimal, octal, hexadecimal, and octal to binary, decimal, hexadecimal, and similarly for the hexadecimal. So let's begin with the row number 1, which is 33 to the base 10. We will simply convert 33 to the base 10 into binary. What we will do is simply divide by 2 repeatedly. So 33 to the base 10 to binary. So 33 divided with 2 will give us 16 and remainder 1. Then 16. So 16 will be divided by 2. This will give us 8, remainder 0. Then 8 divided by 2 will give us 4, remainder 0. Similarly, 4 divided by 2 will give us 2, and 2 divide 1 with 2. So 1 divided by 2 will finally give us 0, remainder 1. Now the thing to remember is that while writing its binary equivalent, we have to see this in reverse order. So like we will start from remainder 1, 0, 0, 0, 0, 1. So it's also mentioned here that read from bottom to top. So 33 to the base 10 is equal to 1 tetra 0, 1, 2 base 2. Now we will go from decimal to octal. It's also very simple. We will just repeatedly divide it by 8. So 33 divided by will give us 4, remainder 1. 4 divided by 8, 0, remainder 4. So 33 to the base 10 is equal to 41 to the base 8. Now decimal back to hexadecimal. It's also simple. You have to just divide by 16 and this will give us 21 to the base 16. Now let's proceed to the row 2. We have to convert 1110101. This is a binary number and we will first convert it into decimal. So by converting binary to decimal, we have to remember a thing, which is we will keep the place values in mind. For instance, if you want to convert the binary to decimal, so you will start from the right side and multiply it with 2 to the base 2 to the power 0. Then you will proceed towards the left, 2 to the power 1, 2 to the power 2, 3, 4, 5, and 6. As it is mentioned here that I have started from this one, which is the most right one, and I have multiplied it with 2 to the power 0. Then this 0 we will add it, and 0 into 2 to the power 1, then plus 1 into 2 to the power 2, 0 into 2 to the power 3, and similarly we will add these all up to 2 to the power 6. So it's very simple. We just have to remember the place values. We have to start from the right and multiply it with 2 to the 0. It's all mentioned over here. Then we'll simply add this and we'll get 1110101 to the base 2 is equal to 117 to the base 10. Okay, now let's proceed towards binary to octal. So binary to octal can be a little bit complicated, but we will make it very simple. So we know that one octal digit is equal to 3 binary digits. Now what we will do is we will group the binary numbers in units of 3, and we will always start the grouping on the right, because one octal digit is equal to 3 binary digits. So from the right side, take group of 3 digits. Like here is 101, we have written 101, then we will written 011 and 011. Okay, and to the left only 1 will remain. Now to compensate the whole digit, we will add some extra zeros as shown here, 001. Then we have a group of 110 and 0. Now we group into decimal as we talked earlier, or we can also remember the shortcut table, which is a much efficient way of doing things. So 001 will be equal to 1 octal, 110 will be equal to 6 octal, and 101 will be equal to 5 octal. So 1110101 to the base 2 is equal to 165 to the base 8. Now let's proceed towards binary to hexadecimal. It's also very simple. We will in the previous one we grouped into 3. Now we will simply group into 4. As you can see, we have grouped into 4. We have started from the right, and to components we have added a 0. We convert each group into decimal and we will get 12 to the base 2 and if it is 275 to the base 16. To all structures converted into octal, binary to hexadecimal, these are almost similar. Now we come to the row 3. Let's convert octal, which is 70 to 703. So 7 octal to decimal we'll first convert. So 703 to okay, we have to convert it into base 10. So very simple. Just remember that place value concept. Start from the right and multiply it with 8 to the power 0 plus 0 into 8 to the power 1 plus 7 into 8 to the power 2. You'll just add them and you'll get your final number, which is 451. So 703 to the base 8 is equal to 451 to the base 10. Now let's go octal to binary. Now convert each octal to binary. So the easier way to proceed is we have to convert each octal to binary. So let's convert this 7 to binary, which is 111. 0 binary is 000. 3 equivalent binary is 01. So 703 to the base 8 is 11000011 to the base 2. Octal to hexadecimal will be like we will first convert octal to binary and then binary to hexadecimal. This is a much easier way of doing things. From shortcut table we know that the 7 is equal to 111 in the shortcut table, and 0 is 000, 3 is 011. So 703 to the base 8 is 1110001 to the base 2. Now this is our binary equivalent. Now we will convert this binary to hexadecimal. So we will simply use that grouping method. We have to group this number into 4. We start from the right side, add zeros to compensate. So this 001 to the base 2 is equal to 1 to the base 16. 1100 is equal to C to the base 16, and 0011 is equal to 3 to the base 16. So 703 to the base 8 is 1C3 to the base 16. Now this is because of the shortcut table. So to make things easier, we need to remember that shortcut table. This is how I solved these questions very efficiently. Now we will convert hexadecimal, which is 1AF. This is the last row. So 1AF will be converted to decimal. Like we will use the place value method. So start from the right. So let's start from the right. So F equivalent. So here F equivalent is 15, and we will multiply it with 16 to the 0, since we are converting hexadecimal to decimal. And similarly, A equivalent in the shortcut table is 10. So 10 into 16 to the power 1 and 1 into 16 to the power 2. Simply add and you will get your answer. Similar cases with hexadecimal to binary. You have to just use the shortcut table. 1 is equivalent to 0001, A is equivalent to 1010, and F is equivalent to 111. Just write them together from the left. So 0001, 1010, tetra 1 2, or you can just skip the 0 and write it as 1101 01111 to the base 2. Let's move on to the last conversion, which is hexadecimal to octal. So use binary and convert to octal. Okay, now we have to write first of all this hexadecimal number into binary. So we have earlier converted this into binary. Now we will use this binary number and group it into 3, and as explained earlier, we will use this grouping method. We will group from the right, group into 3, so 111, 101 and 110, and just write its equivalent from the shortcut table. You will get 1AF16 is equal to 657 to the base 8. So we have done all the conversions. So our final conclusion to this assignment is this completion of table, in which we have mentioned all the values which were required by this assignment. So thank you very much for watching this video. I hope you will have a complete concept of this. Thank you very much.